Okay, we have here another integral today. We've got the integral of 1 over 1 plus sine x all squared dx. And this came up recently doing another problem, and I found it was a pretty nice case to use the Weierstrass substitution. For this substitution, I have all the formulas we need over here to the right. I've derived these in previous videos, so I'll provide a link to that if you don't know where some of these formulas are coming from. But it is kind of an unusual substitution as we're substituting for tan x over 2 when we don't have that in the problem. One other identity that I added on here that you don't usually see with the Weierstrass substitution is we've got this expression for 1. I just put that down because I want to use that for the 1 here. You can see with the 1 plus t squared in the denominator, it's going to help us with this simplification. So now to get started with it, we'll go ahead and we'll start with the dx. So for the 2, we'll bring that out front of the integral, and we're going to have just dt, and I'll bring the 1 plus t squared out here for now. Then in the denominator for 1, we'll use this identity, 1 plus t squared, just so that we can have a common denominator. Sine x, we'll use this, 2t over 1 plus t squared, all squared. The thing that's different about this example of the Weierstrass substitution is just having everything squared. I've done probably a lot where it was just 1 plus sine x or 1 plus cosine x or something like that. So in order to get nice cancellation here, I really want this to be squared to have everything cancel out. So I'll just multiply in the same thing in the numerator, so we're not changing it. Then that way, now that we've got the same exponent, this is going to cancel with this and this. But then what we're left with here, t squared plus 2t plus 1, I can write that as t plus 1 squared, but everything is squared. So this I can actually write as t plus 1 to the 4th. So let me rewrite it, clean it up. So we'll bring in this 1 plus t squared. And let me keep the order straight. So let's do this as 1 plus t to the 4th right here. But then from here, this integral is really not too bad because it's just something we could simplify with algebra. We can't do long division as the power in the denominator is greater than what's in the numerator. But you know what I think I'll do? Let's clean it up with the u substitution. It's going to be about the same either way. We could kind of create a 1 plus t, but let's just do the u substitution. I think it's going to be a little clearer. So if we do u equals 1 plus t, then du is going to be equal to dt. And I can rearrange for t, and we get t equals u minus 1. So then going ahead with this, now t squared is going to be, let's just do it on the fly. So t squared is going to be u squared minus 2u plus 1. And then this right here just becomes a u to the 4th. And now dt is going to be du. But then we can just divide in the u to the 4th and break it up into a bunch of little power rule integrals. So the 1 plus 1 is going to be a 2. So now starting with the constants, 1 plus 1 is 2. I can multiply that out. Actually, let's change this to a 4. And then when we multiply in u to the 4th, I can write that as u minus 4. So then next, let's deal with the u squared terms. I don't really know what order I'm going in. Sorry about that. So then we'll have u 4th into u squared is going to be u minus 2 du. And I don't really think we need this stuff down here. We never even used cosine. It was just kind of for show. So then next we have this minus 2u here. So multiplying minus 2 times 2, I'll have a minus 4 in front. And then dividing u to the 4th into a u, this is going to be the integral u minus 3 du. Go ahead and integrate this. First one's going to be minus 4 over 3 u cubed. This one's going to be minus 2 over u. And then this one here is going to become plus 2 over u squared. And then all we need to do is just back substitute in order to finish it. But let's get it all the way back to x. So let's see, we said that u is equal to 1 plus t, but t is tan x over 2. So I can write this as 1 plus tan x over 2. And so we'll substitute with this value. So what we're left with is going to be minus 4 over 3, 1 plus tan x over 2 cubed, minus 2 over the same thing, 1 plus tan x squared, x over 2, and then plus 2 over 1 plus tan x over 2, add a plus c, and that's it. And of course, you could simplify this further, get a common denominator, get everything like this one, 1 plus tan x over 2 cubed. I did check, and they did it that way on Wolfram Alpha, and it looks a little better. It's more compact, but I think I'm going to call it good and leave it the way it is. Okay, that's it for today. Thanks everyone for watching. Have a good day.